Welcome to True Projects. In this video, we are going to discuss about the project which is object detection using faster RCNN. So let's understand what is the project about. So what is this object detection? Object detection, it is like identifying and labeling the things in the pictures or videos and drawing bounding boxes around them to show where they are. So detecting these objects is important because it helps us to find the objects accurately, no matter how big they are or where they are in the picture. So this is really useful for things like watching over places with cameras, making self-driving cars safe, and help robots to figure out what's around them. So in this project, our goal is to improve how we detect objects using advanced deep learning tool called FasterRCNN. So in this project, we are going to propose FasterRCNN algorithm. So by using this FasterRCNN, we want to make object detection easier and more accurate to find things, which is important for tasks like surveillance and self-driving cars. So traditional methods for finding out objects, they aren't always great, like using certain patterns or sliding windows because they can make mistakes, especially when things get busy. So in this project, we are proposing faster RCNN for finding the objects. Unlike the old methods, faster RCNN combines two important parts. One, a region propositional network and a neural network to learn and get better at identifying things. So this not only makes it more accurate, but also faster because it shares the work between these two parts. So with faster RCNN, we can find objects more precisely, which is really useful for a lot of things like security cameras and self-driving cars. So this is all about our project. Moving on to the algorithms used, we have used faster RCNN as I have mentioned you already. As the front end, we have employed Flask. That is, we integrated Flask with SQLite to develop a web application to deploy a project. So what is this Flask? Flask is like a lightweight web framework for creating websites using Python. We used Flask in this project to make a website where people can interact with our object detection system. So with this Flask, we can set up features like sign up and sign in using a simple database called SQLite 3. So users can upload images on the website for analysis. And this Flask helps to manage all these interactions by directing them to the right parts of a project that is backend, where the images are processed and predictions are made. So this way users can easily use the project through a web browser. So to implement this project, we need software and hardware requirements. So coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So moving on to the hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. So now let's execute the project. To execute it, we have to open the code folder which contains source code files. So these are the source code files in our code folder of the project. Let's understand each file, how will they be used in the project. So let's explore the first folder, that is dataset folder. Here there are two subfolders, one is train folder and the other one is validation folder. So in the train folder, we have two more subfolders, one is images and the other one is labels. So here in the images folder, we have image files that are images that will be used for training the faster RCNN model. So we'll be using all these images for training the faster RCNN model. Get back. Moving on to the labels folder. So these files that are label files, they contain annotations or the labels for objects in the corresponding images. So each label file, it corresponds to an image file in the image folder. So for example, this file, it corresponds to this image and this file corresponds to this image, and that label file, it provides details about object locations and class index within this image. So similarly, we will have for all these 5,885 images, we'll be having same 5,885 label files. So here you can see there are 5,805 label files for all those images. So we'll open a image file and I'll show you a sample. Here, each line it represents a detected object. So there are multiple objects detected in that first image. Here, in each line, we have one class index and followed by its bounding box coordinates, which are normalized to image dimensions. So this 0 represents one type of object, 3 represents another type of object, 4, 2. So in such a way, all the class indexes represent different types of objects. Coming to bounding box coordinates, this is the x limit, this is the y limit, and this is the width and height of the bounding box. That is detected objects bounding box. So now close this, get back. In validation folder also we have image folder as well as label folder. So I'm opening the images folder. Here there are 549 images. In train folder we have 5000 change images and in valid folder we have 549 images. So for all these 549 we have label files also. So get back. We'll be using this train folder to train the faster RCNN model and validation folder to evaluate the algorithm built on the unseen data. So now get back. Coming to the sample folder, these are the test cases using which we'll be detecting objects in the images. So we'll be using all of these images in the front end to detect the objects. Get back. So moving on to the static folder, this folder contains files related to project styling and interactivity. They include CSS, JavaScript, and Bootstrap files. So coming to the templates folder, here lies all the HTML pages utilized in the project. They are index.html and about.html, etc. And this each HTML file represents a different page of the website, which provides the structure and the layout for displaying content to the users. So this is app.py file. This is a Python file which encompasses the front-end logic of the project. And it handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. So this is the model folder in which we have files related to algorithm information. And this will be loaded into the project code during runtime. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So this is the signup.db file. This file is a database file which is used to store the user information. Now let's execute the project. To execute it, we have to copy the path of the code folder from the address bar of the file explorer. So I copied the path. Now we have to open the Anaconda prompt. So using the command cd followed by the space, we need to paste the copied path and then click on enter. Here we can observe that current directory is changed to the code folder's path. Now we need to compile app.py file by giving the command called python space app.py and now click on enter. This command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and port. So this is the localhost and this is the port. Now we need to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Here we need to paste the link and now click on enter. So this is the web page of the project, which is displayed in the browser, and this web page is developed using Flask framework. So we need to sign up first. So click on sign up and enter all the registration details if we are registering newly. I already registered and I have an account already, so I'll directly sign in. So click on sign in. Here we need to provide our username and the password, which are our credentials to login. So now click on login. We have logged in successfully and we are redirected to detection page. So here we can see a choose file button. Click on that for uploading the images. So click on choose file. So these are the images using which we'll be detecting objects from the image. So let's upload the last image. Click on open. Here we can observe that image is loaded. Now click on submit. So here we got the detection for the uploaded image. So this is the image uploaded. This is the original picture of it. And here we have the detection from the picture. So here we can observe that there are multiple objects detected. A car has been detected and a bounding box is drawn around it, and bus is also detected and a bounding box is drawn around it. Here we can observe that a person is detected and label it as person, and also traffic light is detected and labeled it as traffic light. Similarly, we have other objects detected in the same image. So let's upload some more images. Click on choose file. So this time we'll be uploading this image. Click on open. Image is loaded. Now click on submit. So here we got the detection. A bicycle is detected from the uploaded image. So, and it has named it as bicycle. This is the original picture, and here we have the detection from the picture. That is, bicycle is detected. So let's upload some more images. Click on choose file. Now we will be uploading this image. Click on open. Image is loaded. Now click on submit. So here we got the detection from the uploaded image. So this is the original picture which is uploaded, and here we got the detection from it. So here we can observe that a bus has been detected and a bounding box is drawn around it, and there are two persons detected and green color bounding box is drawn around them. Let's upload some more images. So now we will be uploading the first image. Click on open and now click on submit. So here we got the detection for the uploaded image. This is the original picture, and here is the detection from the picture. So we can observe that a TV has been detected and a keyboard is detected. Mouse is also detected and a bowl is detected from the uploaded image, and label it as TV, keyboard, mouse respectively. So let's upload one more image. Click on choose file. So now we will be uploading the second image. Image is loaded. Now click on submit. So here we got the detection. This is the original picture, and here we have the detection. So here two objects are detected. One is horse and the other one is person, and labeled as horse as well as person respectively. Let's upload one more. Click on choose file. So here we'll be uploading the third image. Click on open and now click on submit. Here we got the detection. We can observe that a boat is detected and a person is detected, and a bounding box is drawn for both boat as well as person. And this is the original picture of it. Let's upload one more. Click on choose file. And now we will be uploading this image. Click on open and now click on submit. Here we got the detection from the uploaded image. So this is the original picture which is uploaded, and here we have the detection. So here we can observe that a cat has been detected. Now let us upload images from the Google and see the detection. So open a new tab first. Search for an image. So we will search for an image related to person riding a bicycle. So we'll be saving this image. So I'm saving the image. Get back to the application, that is web application. Click on choose file. So we have saved image here. So this is the saved image. Sorry, this is the saved image. Now click on open. Image is loaded. Now click on submit. So here we can observe that two objects are detected from the image. One is bicycle and the other one is person. So this is the original picture uploaded. Let's upload some more images from the Google. So get back to the new tab. Now we will search for images related to boat. So a person and boat. So let us upload this image. I've saved the image. Get back to the web application. Click on choose file. So we have saved this image. Click on open. Image is loaded. Now click on submit. So here we got the detection. This is the original picture and here is the detection. So a boat is detected and a person is detected from the image, and here also a boat has been detected. Wherever the object is detected, application is drawing bounding box around that object. So here, wherever object is detected, bounding box is drawn around it. So let's save some more images from the Google. Get back to the new tab. Let's search for cat related images. So we'll be saving this image. Get back to the web application, click on choose file. So we have saved this image. Click on open. Image is loaded. Now click on submit. So here we got the detection from the uploaded image. So this is the original picture and here we have detection from the image. We can observe that a cat has been detected. So let's upload some more images from the Google. So get back to the new tab. We will search for images related to vehicles on road. So we'll be saving this image. Get back to the application, click on choose file. So we have saved this image, click on open and now click on submit. So here we got the detection from the uploaded image. So this is the original picture which is uploaded and here we have the detection results. Now click on sign out. In this way, just by uploading images to the system, then the application, it will detect all the objects which are present in the image. So the project demonstrated the effectiveness of the FasterRCNN in enhancing object detection capabilities by leveraging advanced deep learning techniques. FasterRCNN significantly improves both accuracy and efficiency compared to traditional methods. So the successful implementation of the FasterRCNN underscores its potential for revolutionizing real-world applications such as surveillance, autonomous vehicles, and beyond.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.